All right, let's have example 5. You see that example 5?
Yes.
Okay, copy that one. Copy that example 5 also. So they want us to calculate for part A, that is 5q minus 3p, of which here we shall have a scalar times the matrix q minus a scalar 3 times the matrix p. Okay, so when you try to substitute the matrices in this expression, we shall have this as 5 into the matrix P, which is 5. No. Is it? Matrix Q. So when you
2,
substitute,
3.
that is 14.
No.
We are
Yes.
substituting there, matrix Q. 14, 2, negative 8, 6. Then minus 3 into the matrix P, which is 2, negative 3, then 2, 1. Is it clear?
Yes.
Okay. So here, before we subtract, we are going to first multiply these scalars. Okay. The scalar 5 multiplied with this matrix, and then the scalar 3 multiplied with this. Okay. And then after we shall subtract, we are following the board mass. We first multiply before we subtract. So this will be the 5 times 14. What do you get? 5 times 14.
70.
You get what?
70.
70.
Yes.
Okay, that is 70. And then 5 times 2, you get?
10.
Then we have 5 times negative 8.
Negative 40.
Negative 40. And then 5 times 6, you get?
Negative 30.
You get positive 30. Good. Then minus, we are going to multiply a 3 inside here. That will be 3 times 2, you get 6.
6.
3 times negative 3, you get? What do you get? Negative 9. Good. And then 3 times 2, 6. And then 3 times 1, you get? 3. Correct. And then after that, we subtract the two matrices that we have obtained after multiplying the scalars on the given matrices. When you try to subtract, you know subtraction is the same as addition. You are going to subtract the corresponding entries in both matrices. 70 minus 6, you'll get 60.
64.
And then, okay, 64. Then
9.
9, are you sure? When you said 10 minus negative 9, you get 19. Very good. Yes, this negative and this negative, they will add up to, they will change to positive. Okay,
Yeah.
so that is positive 19. And then negative 40 minus 6. This one also
Negative 46.
will increase. Okay, that is negative 46. And then the 30 minus 3,
27.
you'll get 27. I think you can work out the part B.
Yes.
You can work out part B. I'm giving you 2 minutes to give me the answer.
Okay.
2 minutes, 2 minutes. And the countdown here.
Finished. Teacher, finished.
Elizabeth,
Yes.
you are done, eh?
Yes.
Okay, what do you have? What is your answer?
23.
23 here, then here,
21.
21, and here,
8.
80,
28.
28, then here,
7.
7. So that is what you have, Elizabeth.
Yes.
Okay, that is the answer we have from Elizabeth. If you take that, the correct answer is that. Yes, that is very correct. Who has a different answer? If your answer is different from that, tell us so that we can correct you. Huh? Okay, all of you have got this as the answer. Eh? Okay. If that is what you have obtained as your answer. Hmm? Your background is making a lot of noise. Okay. All right. So that is it with the solving equations involving matrices. The rest I'm just going to give you an exercise to attempt. And then before we get the exercise, let me first explain what we mean by a zero matrix, or what we call a null matrix, and an identity matrix. We shall get this identity matrix in details afterwards when it comes to solving simultaneous equations using matrix method. Zero matrix. A matrix with all its elements, or a matrix with all its entries zeros. That matrix is called a zero matrix. It is called a zero matrix. Do you hear me? Do you hear me?
Yes, teacher.
Okay. So if you see any matrix where all the entries are zeros, for example, 0, 0, 0, 0. This one is called a zero matrix, or a null matrix. It can be of order 2 by 1, 0, 0. That one is also a zero matrix. It can take any order. It can be 3 by 3, 0, 0, 0, 0, 0, 0, 0, 0, 0. For as long as all the entries are zeros, That matrix is called the zero matrix. And when you try to look at the properties of this matrix, if you have a zero matrix O, and you add it with another matrix A, which is not a zero matrix, you find that you get the same as matrix A, because 0 plus any number, you get that number. Okay, so the same applies to matrices. If you have a zero matrix O, assuming our A is 2 3 1 0, no, okay, let me use 6. If this is A and this is our zero matrix, our O, a narrow matrix, if you add these two, you find that you get the answer as matrix A here. Are we together?
Yes.
That is one property. Then when you look at the subtraction, it will change a bit. If you say A minus that is zero matrix, then the result will be A. And if it is the zero matrix minus A, then it will be negative of A. All the entries will have the negative on them, okay? All the entries in A will have the negative in that A, okay?
Teacher, let me ask, I have a question.
A.
So let's say we are multiplying the 0 and the A. So the answers will be 0.
Let me answer. That is the second property I was going to talk about. And another property is multiplication. If you get the matrix O, which is our narrow matrix, times another matrix, let's say matrix A, this will give you the same answer as the O. It will be a narrow matrix as a result, okay? That narrow matrix times the matrix A, you get a narrow matrix. It will give you the same result as getting A times that narrow matrix. The same result you get. So the order here doesn't matter. So this multiplication of a narrow matrix with any other matrix is commutative, whereby O times A is the same as A times O. The order does not matter for a narrow matrix. But take a note, this is true for only multiplication between a matrix, which is not a narrow matrix, and a narrow matrix. This one here. It is true for only these two, okay? Otherwise, if you have another matrix B, let's say 1, 2, 3, and negative 2 or negative 3, A times B is not the same as B times A. Take a note, we talked about this one last time, okay? Am I clear on that, please? Say yes or no.
Yes.
This is true for those two, but if any of this is not a narrow matrix, then it is not true, okay? Those are the two properties that you can talk about when you're looking at a zero matrix, or what we call a narrow matrix. Then we have what we call an identity matrix. An identity matrix is a square matrix whose entries in the major diagonal are ones and the rest is zeros. When I say like that, do you understand what we call an identity matrix or a unity matrix? Yes or no?
Somehow.
Somehow. All right, I will explain. An identity matrix, or what we call a unity matrix, I repeat, it is that matrix whose entries in the major diagonal are ones and the rest of the entries are zeros. This is what I mean. And another condition I've put, of course, is that An identity matrix must be a square matrix. Do you remember a square matrix? Huh?
Yes.
What is a square matrix? Who can tell us? What is a square matrix?
Let me try.
It is what? You have forgotten, you people.
No, I'm trying. I'm trying.
You try.
A square matrix is a matrix that is multiplied by itself twice. But it multiplies itself twice.
No. No. Hey, you have forgotten what we discussed last time. I said last time that a square matrix is that matrix whose number of rows is equal to the number of columns. You have forgotten. If you have the number of rows equal to the number of columns in a matrix, then that matrix is called a square matrix. So in that case, a 2 by 2 is a square matrix. A 3 by 3 is a square matrix. A 4 by 4 is a square matrix. Okay? And we are saying a unity matrix or an identity matrix has to be a square matrix. And another characteristic of this matrix is that if it is a 2 by 2, if it is a 2 by 2, then the entries in the major diagonal are ones and the rest of the entries are zeros. This is what we call the major diagonal. And then this is the minor diagonal. Have you seen that? So this is a unity matrix. 1, 0, 0, 1. If you have these entries as ones and the rest of the entries zeros, then this is a 2 by 2 square, a 2 by 2 unity matrix, a 2 by 2 unity matrix. If it is a 3 by 3, it will look like this: 1, 0, 0, 0, 1, 0, then 0, 0, 1. This is the major diagonal. Okay. For as long as you have these entries in the major diagonal, for as long as you have these entries in the major diagonal, ones, a 1, a 1, a 1, and the rest of the entries zeros, then this matrix is called a unity matrix. Unity matrix. Or it is sometimes called identity matrix. Is that clear?
Teacher, I have a question.
You ask.
I have a question. So, like, is it a must or it has to be one or other numbers can be put there?
No. The answer is you must have ones, a 1, a 1, a 1 in the major diagonal, not any other number, not any other digit. Am I clear on that?
Pardon?
In this major diagonal, you must have 1, 1, 1 as the entries in the major diagonal. I've showed you what we call the major diagonal. If you have this matrix A, equal to 2, 3, 1, 4. This is what we call the major diagonal. Diagonals, the one slanting to the left. And then this is what we call the minor diagonal. This is minor and this is major. Okay? Are you getting me?
Yes, teacher.
This matrix,
Okay.
this matrix here, A, yes, it is true that it is a 2 by 2, which means it qualifies to be a square matrix. This matrix here, you see, this A is a square matrix. Do you hear me?
Yes,
teacher.
Yes, it is a square matrix because the number of rows is equal to the number of columns. But this matrix A is not an identity matrix. It is a square matrix, but not identity matrix. Why? Because in the major diagonal, we don't have ones. And the rest of the entries are not zeros. It can be square, but not identity. An identity matrix, which we shall call the I, capital I, must have all the entries in the major diagonal as ones and the rest of the entries as zeros. And even this one is I, which is a 3 by 3. We said the 3 by 3 means that matrix is a square matrix. And to qualify as an identity matrix, it must have all the entries in the major diagonal as ones and the rest of the entries as zeros. Okay, so this is identity, this is identity, but this one here, A, is not identity matrix. But all these matrices I have here, they are square matrices. Are you getting the difference?
Yes.
yes.
Yes? Yes, okay. So that is what we mean by an identity matrix or a unity matrix. So we can have an example on how we can multiply that identity with any other matrix. But of course, under the properties, we shall see that if you have the matrix I, which is identity, times any other matrix A, the result you get will be the matrix A. And if you change the order here and you say A times I, then this will be the same as A, meaning this property under multiplication is just like that of a zero matrix, okay? That I times A is just the same as A times I. Under multiplication, you'll get the same answer, okay? You'll get the same answer. So we are going to have, we are going to take an exercise. We are remaining with a few minutes here. We are going to take the exercise. Please, this time, do the exercise.
Teacher, your number.
My number. You didn't take my number the other time. Okay.
I lost it.
Okay, I'm going to give you my number, but please, I'm saying do the exercise, send it on my WhatsApp. I'll mark and give the feedback. It will help you understand whatever we discuss during these lessons, please. Because when I come back, I check the errors, the mistakes, the misconceptions, then I clear them when we come back. So if you don't do, then probably you may go with a misconception. Maybe you did not understand something, but I can clearly see it if you attempt to do the exercise and I mark it, okay? You should feel it. No one should force you to do the exercise, okay? Do it and send on the WhatsApp, okay?
I don't